Hey, what is up, everyone? Day 12, having a code here. We got a minute before we pop in. So, we're doing pretty good recently, right? Let's check over on the leaderboard real quick. So, a few good days recently. This one also wasn't so bad. Not a great second part, but going again for let's try like 1,500, 1,000 here. I wanted to break 1,000 once and we did it, and now I just have the, can't get the taste out of my mouth. Want some more. Whew. All right, 20 seconds left. I don't know. Just gotta do the good old, like, to int, some of that. Right. 3, 2, 1. Here we go. Let's see. Oop. I kind of have to comment out these bits. Just kidding. Let's do it. Okay, A's, B's. Cool. So that looks like very familiar. Oop, gotta go to the right thing too. Alright, so let's see. Try contacting the elves using a handheld device, but the river you're following must be too low to get a decent signal. You ask the device for a height map surrounding area. Your puzzle input height map shows a local area from above, broken into a grid. The elevation of each square of the grid is given by single, so A is the lowest and Z is the highest. Also include the height map are markers of your current position and the location that you should get the best signal. Your current position S has an elevation A, and the location you get to get the best signal E has an elevation of Z. You'd like to reach E, but to save energy, you should do it in as few steps as possible. During each step, you can move exactly one square up, down, left, or right to avoid needing to get your climbing gear. The elevation in your destination square can be at most one higher than the elevation in your current square. Okay. So you can go to M, or you can go from M to N, but not to O. Okay. Here your start in the top, whatever. Okay. But eventually, okay. What is the fewest steps required to move from your current position to the location where you can get the best signal? So this is like a pretty well-known problem. Like this is, I'm pretty sure, just Dijkstra's algorithm. So we are going to try that, I guess. Okay, so the first thing we need to do is we're going to need to read this in. So we'll do lines, and we're actually pretty fine with just this. So val map. Okay. And then we're going to need another thing here. This is going to be the number of steps. Let me just confirm. This path reaches the goal in 31 steps. Okay, so that's fine. So we're going to do steps, and this is going to be mutable list. We're just going to keep a list of map.size, and then each of these is going to be a mutable list. We're going to do map 0 dot size. So it's going to be the same size as the thing that we just made. We could have done this as like we could have done this as coordinates, but this will be good. I'm just going to return 0 here. Okay, and then the next thing is going to be val. We need a priority queue, so priority queue, and this is going to be a coordinate. Actually, can we just do a triple? Yeah, so it's gonna be int. We could also be doing a star here, I guess, but we're not going to do that because it's a little too fancy. Okay, so first we're going to have to find the start and end, I think. Val s equals map dot. How do we even do this? I don't know. We're gonna find the starting coordinate, and then we're gonna walk from there. And the priority queue is going to, since everything is only one step away, as soon as we get to it, as soon as we get to the end, we'll know we're there. That sounds stupid, but I'm gonna say val s pair int. And then what I actually want to do here is map dot indices dot for each. This is our row, and then map r dot indices dot and this is our column, and then I'm going to say if map rc equals s, then then s equals pair, and we're just going to do rc like that, and then we're going to break. I'm going to pull this. I really don't like breaks, so find start. Okay, this will just return, and then throw, and this is fine. Let's pass the map into this. This feels maybe stupid, maybe it is, but I don't know. Okay, so return, okay. I like that. This, oops. Okay, and then let's just print line s. And we'll just check that we're finding the right thing. In this, it is 0, 0. Yeah, so forget this. Okay. Now what we're gonna do is we're going to pq dot add. Probably need a comparator on this actually, right? Yeah, I feel like we do. Sorry, let me just priority queue. I should have. Oop. Kotlin. Yeah, dude. Look up the quick examples. No, I know how to use it. I just want to see. That's fine. With comparator. Okay, yeah. Oh, compare by. Oh, okay. So compare by, and then it dot third is going to be our, and yeah, compare by ascending. That's good though. Okay, and then we're gonna add in this. So we're gonna say triple s dot first, s dot second, and then 0. Okay. So I'm gonna say while pq dot is not empty, and we're just gonna take next is pq dot pop poll. Does this do what I want? I think it does. result. Yeah, it takes the first element off the list. Okay. Oh yeah, because it's priority queue, so you can't do anything else. Okay, then we're gonna find. Actually, we're gonna check if this is the end. Add to visited, find neighbors. Okay. So val c equals, we're gonna go into the map and we're going to do next dot first, next dot second, and we need to make sure that we're keeping these consistent. So when we found it here, it's row column, so row is the y, so yx. Okay, and then so we'll say if c equals e, return next dot third. I'm gonna print here. We found it, and okay. Else, what we need to do is we need to say. So actually, the first thing we need to do is we should be checking to see if we've been here before. So if we're actually going to put -1 in all of these for the step. So if step, what is this? So this is the minimum steps for this spot. So next dot first, we're doing the same things. Next dot second is not equal to -1. We're just going to continue. Okay. This is, we've been here before. Okay, this is, we're at the end. Okay. Now what we're going to do is, let's take these and put them down here just to make us happier. So now we're going to get neighbors. Okay, this is kind of annoying, but let's see. What I can actually do is I do have this chord, so I can construct this with next. Oh, I can't do to pair. That's fine. Next dot first, next dot second. Oop. And okay, so I can actually do dot. I actually have these like bounded neighbors things, so I can get the neighbors. And this is going to bound it in, let's just get the val height equals map dot size and val width equals map 0 dot size. Okay, and then I can do bounded in width and height, and then this is just any direction because we can go left, right, up or down, right? Just making sure it's like in a cross, right? We're going to start by top. You could start by moving down or right. Okay, so neighbors. Okay, and then what I'm going to do is I'm going to turn these into okay, to do for n in neighbors, and then var val cn, that's character of the neighbor. And so we're just going to check to see row first, and then column. And then we can say if cn minus c, does this work now? Cn dot code minus or is it c dot code? We want to check if they're at most one apart, right? So actually we can just say if this is in this range, right? Then this is valid. We can go here. And so we should probably check here as well that we haven't been here, right? So if it's that and because if it's already in steps, then we've been to this spot before actually. So here we need to actually record that we've been here equals next dot. Okay. And steps, step, where is this, n dot r, n dot c equals -1. I hope this doesn't have to change later, but that's fine. Okay, now we can go here. So what we're going to do is we're going to say the cost to getting here is n.r, n.c, and then however long it's taken us to get where we are, third plus 1. Because the third one in this triple is how many steps we've taken to get here. So if we're going to go visit this neighbor, it's going to take one more step to get there. Okay, what do we do here? So this fills out the neighbors, right? We go and we get all the neighbors from this magic. We'll just do this. And then for each one, we see if we can go up the hill and if we have not been there before. And then we go there, add visited, find the neighbors, I think. This might be it. No. Okay. We didn't find anything. We didn't find anything. Okay. So while PQ is not empty. Oh, we're probably just hitting this right away, right? So the other thing we have to do is once we find if haven't been here before. Oh, you know what? Actually, there's a problem here. S is A, right? Starting position. This is your current position and location that you want to get to. Your starting position has elevation A. Yeah. Okay. So let's do that here. Oh, actually, we'll do it where? Here. If C equals S, C equals A var C equals E, C equals Z. And actually we're gonna have to jam this somewhere else. That's kind of annoying, dude. Need to put it right here too. So we should have done this a different way, but this is just the stuff that checks if we can go somewhere, right? So we haven't been here before. Okay. So let's see. I'm gonna say visit. This is fine. All right. So I mean, I definitely screwed something up here, right? So let's see, A, B. I mean, I'm sure that there's here, let's just change this to fun, get height, C char, and we'll just return char, and we can put this in here. This is like, now they're like, you'll never find the answer, which is true. All right. Hopefully, hopefully this is one of those where, you know, there's maybe a bunch of extra, a bunch of work up front, and then. So we're gonna just do val c height equals get height of c, and then okay, this is fine if we're at the end, and then otherwise we really don't want to use otherwise we really don't want to use c itself. We want to use c height. So I think it might just be this spot, and then this we can do val cn height equals get height cn. Okay. I think that's fine. I don't think that actually is going to change anything here, though. Okay, so I've actually never like tested this thing, so I should probably like test like print line found neighbors for. I know, debugging is pretty sweet. All right, let's see, found neighbors. Okay, so like 3, 2, I have 2, 2, 4, 2, 3, 1. Okay, that looks pretty good. And then this visit, we can just go left or down for these. All right, I'm like pretty sure that this works. So what's our issue here? We are like running into a dead end somewhere. Maybe we're filtering out something here that we shouldn't be. So maybe say neighbors added equals 0, and then let's just kind of work through this maybe. Because I feel pretty confident about this. Like let's just make sure we're doing RCs everywhere for a second. I mean, I don't know why I would have switched those, so this is a little bit frustrating, but Maybe I'm pulling these off in the wrong order. 1, 1, 2, 2, 2, 3, 3, 3, 4, 5. That seems good. Maybe just don't do that. Doesn't really matter because we're like checking below, right? But it seems like we're kind of going in circles there. So, So what path are we supposed to be taking here? Oh, I didn't actually finish doing this. Let's finish doing this first. Added. Okay. And then we want to also print the. Okay, so I feel happy for this, but actually, you know what I should do for this? I should just make this a mutable list of int, and then I'm just gonna do this, and this will be kind of silly, but last. Okay. Okay, so 3, 2. So if this is 1, 2, 3, and here. Oh, 3, 2. Okay, but like I could have gone down, right? Yeah. Right, so 0, 1, 2, 3, then 2 over. Why is it not finding this? This has got to be a bug in my neighbor's code, right? There's got to be a bug here. This is unfortunate. Like, it's kind of why you got to test stuff. Didn't. So found neighbors for 3, 2. So it should be finding 4, 2. Oh no, 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 no. Oh no, these are mixed up in column. Okay. I had it all good, and then okay. This should be 0 until there. Okay, 31. Got it. I'm pretty sure that's the right. Yeah. Okay. So that took a little bit because I mixed up frickin'. I know, right after I said, oh shoot, it says we didn't find anything. Oh no. Oh, it's not great. Okay, let's check that out. Oh no. Oh no, no, no. Oh, this sucks, guys. So I'm looking for this one, which like definitely has stuff. Let's do the same thing actually. Let's I want to do this, but for the end, right? Fine. Oh man, that sucks. I'll just print at the end, actually. Just print it here. Okay. Didn't find anything. 2088. So, I wonder, okay, if we didn't find anything, then let's just look at, does this do what I want it to do? I feel like we gotta look at the output of the, like this. Dang it, dude, this sucks. Is this what I want? That should do it in a big grid, I think, yeah. Damn. Like, it seems like we're kind of going all over. So is there actually like areas that we can't traverse here, or? So like E. I don't know, I mean, it seems STR. Oh, this sucks, guys. Okay. Where is this? So I think I can pass. I think I can pass this like a transform. So I'm just gonna say like it greater than oop. It's greater than or equal to 0. Man. Else. I'm just trying to figure out where the heck it's like, where is this breaking down? Okay, so it's in here is where it's not getting to. And let's see. Yeah, so I was kind of looking at how it would do this. It's like R Q P O N N oh man. I'm actually like legit don't even see E M M N M L K oh, it's right here. I H G I mean, I should be able to like literally just look at this and figure out where this is breaking down. This is like super freaking wasteful. I can't believe this. Gosh, guys. Day 12 debug.txt. Oh my gosh. Okay. I like literally just can't think of a better way to do this. Right, so so this thing right here, like these four are the I's. And then H G F E D C. Oh my gosh. Did it get to this? Okay, so this island of A's here, it correctly says that it can't get to that. Okay, so what the heck? It gets to G. So let's see. There's like a little protrusion of 3 right here, so these are the L's. It like seems like it got so it actually gets to this M right here. That's this. So M. What's the key here? It has to get to M. D. E, F, G. I literally don't know what I'm missing here. Does it not go back down to this K? Okay. How do I even debug this? This is crazy. Like M L K. Yeah, it should go back down to this K, and it's not doing that. And why is it not doing that? Like, this code should work. It's right here. It's like, row column. I wonder if the neighbors that come out of this are wrong, honestly. Column X range. Okay, that's good. The width range. Is that what it's doing? So X range is X in width. Okay, seems fine. And then the neighbors. So let's see. Oh my gosh. Okay. List of. Dang it. I like legit don't even know what this is doing. But shouldn't really matter, right? Because it should work in both ways. So the horizontal specs are +1 and -1. Because in this, it's the column. So that's fine, I think, right? If it's horizontal. This is vertical. Yeah, I think that works. Okay, so I do know where the issue is. It's like right here, but I guess I can just frickin' debug that, right? So it's like 30. Or 29. And where's the frickin' column on my thing? 2997, I guess. Let's try that. So next dot first is equals 29. Next dot second equals 97. Oh my gosh. Yeah, this is frustrating. This has been like super freaking close. And we're already 40 minutes in or something. Takes a lot longer when you have the debugger on, but shouldn't take that long. It's only a few thousand, so it's like 100 by 40. Did I change something to get into an infinite loop? let's see. So this is the neighbor that I'm looking at going to, right? And I'm just making sure cn minus. So this would give me like -1, right? Because from m to k, right? So, I mean, I don't know. Seems fine. I don't. Okay, I just bailed out, but I don't actually need it, right? Because I can do 3097. So it says added 3097, visit 3097, and where is that? That's here. So visit 3097, found neighbors. Okay, so I should find 3096. Okay. Yeah, let's just print more stuff. N cn, and then just print this. And let's just print C as well. Okay, go, go, go. Oh yeah, it runs so fast when it's, so 30 space 97. Okay, so visit 3097, 3096. So let's see. Okay, so that's, so I'm really interested in wait, what the heck? This is D 9731. Oh, so this is 31. How the heck did it get to that? Oh yeah, 9731. Never mind, that makes sense. So that must be this one. So okay, so I'm actually interested in 97. Okay, so it added this. Let's see, visits next. Is that not what I think? M J K L M. Oh, this is not, this is fine actually. Did I like misread this problem? Oh my gosh, what is going on, dude? Okay. Here you start in the top left corner. Your goal is near the middle. What the heck? Okay, now I'm like legit confused. C, D, E, F. Okay, I'm just gonna walk through it because I thought I could go from M to K, but obviously you can't. F, G, H, I, okay, J, K, L. So I can't get, okay, L, M, K, L, M, N, okay. Am I stupid? Like, I'm straight up not seeing this. There must be exactly one path. Right? Like... okay, I like literally don't know what's going on. What's going on, guys? Am I just totally missing missing something here? Like L, M. Maybe it's not from up there. Like, okay, A, B. Oh, geez, there's not even any B's around here. That's interesting. C. Okay, so you traverse the C's. So you have to start at D. D is there. There's no other options. D. I can go back to C. That doesn't help because that's the same thing. So we have to go from D to E. Okay, E goes to F. F goes to G. Okay. G goes to H. G could go back to F, but that doesn't help because that's the exact F that we came from. I'm going to zoom out just so I'm not scrolling around at all here. F, G, oop, I want to be here. G, H, I, H, I. These are all together. J, okay, K, okay, L, K, L, okay, M, N, okay, M, L, M. Can you go down as many as you want? That has to be what it is, and I'm just an idiot. At most one higher. Can be much lower than your... Oh my gosh. You gotta read the problems, dude. That's super frustrating. That's so frustrating. Okay. So what I want is... okay, it's this. Yeah, I'm just gonna get wrecked here. That sucks. Okay, You're walking up a hill. You suspect the elves want to turn this into a hiking trail. The beginning isn't very scenic, that perhaps you can find better. Maximize exercise. To maximize exercise, the trail should start as low as possible elevation. The goal is still to get to E. However, the trail should still be direct, taking the few steps to reach the goal. So you'll need to find the shortest path from any square at elevation A to the square marked E. Again, consider the example from above. Now there are 6 choices for starting position, 6 choices for starting position, 5 marked A, plus the square marked S that counts as being at elevation A. If you start at the bottom left, you can reach him out quickly. Okay. So Dijkstra does this, but I am trying to remember how. So because it should be the shortest path to any location. So hold on a sec. So instead of the number being the distance to the starting location, it should be the distance to any A. Okay, so we're gonna copy all of this. I think everything else can stay. Excuse me. Okay. So it's not just if we've been here before, it's if the current place is this has to be less than next dot third. So this means we've been here before in shorter number of steps. Oh, you know what? Actually, this is wrong. So Dijkstra's tells you the shortest path from any spot to every other spot. So what we actually want to do is start with E. So we're going to start at the end. And then we're going to basically reverse. We're not going to shortcut this. We will shortcut it because it'll be the fastest to either one. So start at the end, and then we have to reverse this because now so we can only go one downhill. So it has to be greater than or equal to -1. And then this is saying, and we haven't been there before. I think that's still true. Okay. Let's just cancel these because we're not working on those anymore. Let's see. What is the answer supposed to be? 29? It is 29. So let's do this. Cool. Well, it was a really fast second part, but oh, that sucks. I just missed that one frickin' thing in the first, yeah. Oh, it's frustrating. I missed that one bit. So these are pretty fast. I bet if I look back on my time, I probably had something like pretty close in that amount of time. Yeah. Okay. Well, you know, picked up a few, but only 6 minutes for the second bit. Not the greatest Sunday night. So I can just kind of cover what we ended up doing here, because it's not actually that complicated. This was just like a ridiculous amount of debugging. So thanks for sticking through it if you did. So what we do is we have our map. So this is the height map, right? That's really what this is. And this is like min steps to location. Okay, and we initialize those all at -1. That's like, we haven't been here before. And then we have a priority queue. So what a priority queue does is it orders things based on a certain characteristic of the attribute. So I put triples in there where this is row, column, and then int is the number of steps, so like minimum steps to that location. And I order it by minimum steps. So that means when I pull an element out, it's always the one that's the fewest steps. So it's like the closest to the starting location. And then I just have these for bounds. Not really a lot interesting here. Okay, find the start and add that to our list. And then what I'm going to do is I'm going to go through until this list is empty. And so grab the first thing out of there and just make sure we haven't been there before. If we have, which seems unlikely because in this there's not like anything weighted. It's just like everything's one step, so you can just kind of walk around randomly. Though I guess it's possible to kind of go up and around like that, but we didn't end up doing that. Yeah, so I guess like if you have a bunch of elements, it's possible that something gets added twice, basically. So, but since we're pulling them off based on like the fewest steps, we'll always, like if we're getting here again, that means we've already visited this spot for more cheaply. So that's why we're not doing any like less than comparisons. And then this is like mark this spot as visited with, yeah. Okay, and then after we do that, we're going to check to see if this is the end, and that's what this does. This part, like it says, we find the neighbors, so I just have this utility. I screwed this part up because these are opposite. Of course, I was going to do this with my own utility. And it basically, you can give it a spec, so plus is like, you know, vertical and horizontal, and then it's also going to bound it, so it won't let you run off the edge of the map. So that's kind of neat. And then this is just debugging code. I don't need that anymore. So what this does is we go through all the neighbors and we see if we can actually go there. This is the bit that basically just trips up the whole time, right? So you can only go one higher. You can go parallel, or you can go as many down as you like. Yeah, so that check sucked. And then this makes sure that we haven't been to the spot. I mean, we already have that check up here, so this is not needed actually. Okay, and then you just add it back to the priority queue if you can go there. And this is actually like throw unexpected. We didn't find an answer. And so that's actually the whole thing, right? So we're like, look at the next one, which again, this is ordered by the fewest steps. So the first time that we hit the end, we know it's the fewest steps to get there, because if there was a shorter path, we already would have taken it. So that's kind of neat. Look at the neighbors, check which ones are valid to move to, and add them back to our priority queue. Again, this is saying like, with one extra step forward. So each time you move, you're obviously adding one step. And then part 2, which is like, very similar, just says, find the shortest path from the end to any A location. And so we basically reverse everything. So we start with the end as the starting location, and then let's see. Yeah, so we start with the end. I'm just gonna refactor this live because this one was actually really frustrating. But yeah, same thing. Start at the end, add it to our queue, and then it is the first thing that's pulled out. We haven't been there before. Mark it as seen, check if it's the end. Here, when we're talking about being the end now, it's like whether it's S or A, right? So any bottom level component. Same thing, neighbors. I mean, I literally copied this code, right? So nothing at all interesting here. Yeah, so that's it. Unfortunately, it took us a while today because, again, there's like one line that I did not read. So read your inputs. But got it in the end, so I will stop getting down on myself, and yeah, we will come back for day 13. Hopefully it'll be a bit faster, so hopefully you'll join us, and